Let's start with the fundamental question that most people think they know the answer to, but really don't. What are policies? You probably think you know, right? Hell, you might even have dozens of them implemented in your cluster right now. But here's the thing. Most of what you call policies aren't actually policies at all. A real policy is a business rule, a guideline, a principle. It's something like never use latest as an image tag because it makes rollbacks impossible and debugging a nightmare. It's databases in Google Cloud must always run in the US East 1 region, those in Azure must run in East US, and AWS databases go into US East 1. These are policies. They're the rules we've established about how things should be done, why they should be done that way, and what happens when they're not. Now, Kyverno, OPA, Kubernetes validating admission policies, well, those aren't policies. They're technical implementations of policies. They're the bouncers at the door, the enforcement mechanism that catches you when you've ignored or weren't aware of an actual policy. They're important, sure, completely, but they're not the policy itself. They're just the way to enforce it. Here's what happens when all you have are, let's say, Kyverno policies. Do you read through them all to learn what should be done and how? Of course not. Let's face it. Nobody does that. Instead, you do something, you apply it, you watch it fail validation, you change it, you apply it again, see it fail different validation, and repeat this dance until you eventually succeed. It is frustrating, time-consuming, and completely backwards. Is this what we expect AI to do? Just be completely oblivious to company policies and keep trying until it accidentally succeeds. That's exactly what happens today. We give AI agents access to our clusters and expect them to magically know our rules. But they don't. They can't. AI acts remarkably similar to people. It knows what it knows from its training, and it needs to combine that knowledge with your company's specific guidelines and capabilities and patterns and policies. Only then does it stand a chance of doing the right thing without constantly failing. The AI has access to general information from the internet, sure, of course it does, but it doesn't have the information specific to your company. It doesn't have the tribal knowledge locked in your head. And that's the problem, because you need to feed it that information somehow. So, where are those policies actually stored? Here's the uncomfortable truth. They're everywhere and nowhere at the same time. They're buried in internal documents and wiki pages that nobody reads. They're hidden in existing code as comments or conventions. They're scattered across thousands of Slack messages and buried in transcripts of Zoom calls that nobody will ever read. But more importantly, and this is the real problem, those policies are locked in people's heads. They're in your head right now. The senior engineer who's been here for 5 years, well, their head is full of policies that have never been written down anywhere. So, how do we feed that information to AI? We cannot extend AI's knowledge directly. At least not with LLMs. Models are what they are. They're trained on data up to a certain point, and that's it. We can feed information into models during conversation, but it's only temporary. The moment you start a new session, that context is gone. So, if we cannot permanently augment what's stored in models, we need a different approach to teach AI. Today, we are specifically focused on policies, starting with the question: how can we teach AI what our company policies actually are? The answer to that question lies in embeddings, semantic search, and vector databases. This is how we bridge the gap between what AI knows and what it needs to know about your specific environment. Now, to be clear, I will not dive into the details of creating embeddings, performing semantic search, and using vector databases right now. I already covered that in this video over there somewhere, right? If you haven't watched it yet, go check it out. Not right now, after this video. I will give you, actually I will not give you anything. That video will give you the foundation you need. Now, this information needs to serve two purposes. First, we need to feed it to AI so it understands what is and what isn't acceptable in your environment. Second, we need to create Kyverno resources as the last line of defense. That way, even if a person or an AI makes a mistake, Kubernetes itself won't allow wrong values in resources. It's like belt and suspenders approach, and it works. So today we will use DevOps AI Toolkit project to demonstrate those principles. You can use that project directly, implement the MCP yourself, or just use it as inspiration to create your own solution. It's completely up to you. Okay, now that we understand what policies are and why AI needs access to them, let's see how we can actually make this work. We are going from theory to practice, and I'm going to show you exactly how to extract those policies locked in your head and turn them into something both AI and Kubernetes can use. As a recap, just to be sure, we all understand, right? Policies exist in documentation, Slack messages, wiki pages, and all those other places I mentioned. We could spend time building scrapers and parsers to extract them, but let's be honest, the most important policies, the ones that really matter, are sitting in our brains right now. They're the tribal knowledge we accumulated over years of experience. The unwritten rules, oh, we always do it this way type of guidelines that nobody ever documented. So here's what we're going to do. We'll use a guided workflow that walks you through a series of questions to extract this knowledge from your brain. This isn't just some survey or questionnaire. It's a structured process that takes what you know and transforms it into two things simultaneously: knowledge that AI can understand and use, and actual Kyverno policies that surface those rules in your cluster. One process, two outputs. That's efficiency. So let's walk through this process. We'll start by telling the AI to create a policy. Now, watch how the system guides us through a structured workflow to extract the policy details. The workflow starts with a broad, open-ended question. At this point, the system doesn't know anything about what you or me or them want to enforce. So it has to begin somewhere. It provides some common examples to give us an idea of what kinds of policies are possible, but really, you could describe any policy you want, any. So let's give it something specific, like a regional compliance requirement for databases across different cloud providers. Okay, now the system needs to understand what types of infrastructure this policy applies to. It is asking for keywords that will trigger this policy. Think of those as tags or identifiers that help the system recognize when these policies should be enforced. This is crucial because later, when AI is working with our infrastructure, it needs to know which resources fall under this policy's jurisdiction. The system takes your initial keywords and expands them into its knowledge of cloud infrastructure. It knows that GCP DB probably means Cloud SQL, that AWS DB includes RDS and DynamoDB, and that databases come in many forms. It's not just guessing randomly. It's using semantic understanding to identify related concepts. Those expanded triggers are critical. They're not just for show. Later, when AI needs to work with our infrastructure, those keywords will be used for semantic search to find and apply the right policies. The more comprehensive your trigger list, the better the AI will be at recognizing when this policy should apply. You can accept all of them, pick specific ones, or add your own. Okay, now it's asking for the rationale. This isn't busy work. The rationale becomes part of the policy documentation that both humans and AI can reference later. When someone 6 months from now asks, hey, why the hell do we force databases into specific regions? This rationale provides the answer. It also helps AI understand the intent behind the policy, not just the rule itself. Now, I was lazy and asked the system to write the rationale for me. It generated a reasonable explanation about performance, latency, compliance, and operational complexity. In a real scenario, you would probably want to provide your actual business reasons. Maybe you have specific compliance requirements, or maybe you just got a better pricing deal in those regions. Whatever the reason, be specific. The system then asks who created this policy. This creates an audit trail and accountability in a way. Now, here's where it gets interesting. The system discovers what namespaces exists in your cluster and asks where this policy should apply. You can make it cluster-wide, limit it to specific namespaces, or exclude certain namespaces. This granular control is important. Maybe your development namespaces don't need the same rigid regional requirements as production. Notice that we are still gathering information at this point. The system needs to know the scope, regardless of whether it will eventually create a Kyverno policy, an OPA policy, or something else. And now comes the magic. The system took all the information we provided and generated two things. First, it created a policy intent. It generated embeddings from it and stored those embeddings in the vector database. This is what enables semantic search later. When AI needs to work with your infrastructure, it can search for relevant policies using natural language, not just exact keyword matches. Second, it generated an actual Kyverno cluster policy with all the technical implementation details. Look at it. Look at how comprehensive this is. The system analyzed the available custom resource definitions in your cluster, figured out which ones are database related based on our triggers, and generated specific validation rules for each and every one of them. It knows that GCP databases are for provider region, Azure uses location, and it created cell expressions to validate them. This isn't some generic template. It's a policy specifically crafted for your cluster's actual resources. So think about what just happened here. The system generated validation rules for over 20 different resource types. If you had to do it manually, you would need to identify which CRDs in your cluster are database related, fetch the schema for each one of them, figure out which fields contain region or location information, write the appropriate cell expressions for each and every one of them, handle both for provider and init provider patterns, and wrap it all in proper Kyverno syntax with namespace scoping. That's hours of tedious work condensed into a few seconds. So the system gives us three options: apply to the cluster immediately, store just the intent for AI guidance without enforcement, or cancel. This flexibility is important. Maybe you want AI to know about the policy, but you're not ready to enforce it yet. Or maybe you want immediate enforcement. It's your choice. Now, to be clear, we could instruct the AI to save the Kyverno policy to a file and manage it through GitOps with Argo CD or Flux, but I didn't set those up for this demo. In a real environment, you would probably want that GitOps workflow. So let's go with option 1 and apply directly to the cluster. Look at it, perfect. The policy has been applied to the cluster. We now have both the policy intent stored in the vector database for AI semantic search and the actual Kyverno policy enforcing our regional requirements. This dual approach means that AI knows about the policy and can consider it when working with infrastructure, while Kubernetes actively enforces it as the last line of defense. So let's verify our policy was stored correctly by listing all the policies in the system. There it is. Our new database regional compliance policy is listed first, along with two others I created earlier. Each policy has a unique ID, description, creation metadata, and deployment status. This is the information that gets embedded and stored in the vector database for semantic search. When AI needs to work with your infrastructure, it can search through these policies to understand what's allowed and what isn't. Now, let's see those policies in action. We'll ask the AI to create a database in, let's say, Azure. Behind the scene, the MCP tool that I'm using today will discover available resources, match them to organizational patterns, and apply our policies. But what we're interested in today is how it uses the policy information we just stored to ensure compliance with our regional requirements. So let's go fast through it until we reach policies. First, the AI starts with a guided workflow to understand what we need. So let's keep it simple. Next, it presents three options. So let's go with multi-cloud PostgreSQL option, the first one. And now, this is the moment where policies come alive. Watch this. The system is applying policies it found through semantic search. First, the cloud provider composition. Since you want Azure, this should be Azure PostgreSQL. That's enforcing one of the policies I created earlier. Second, and more importantly for our demo, look at the region options. The system is specifically recommending East US for Azure. Now, this isn't random. The MCP tool performed a semantic search. It found our database regional compliance policy. It understood that we are creating an Azure database, and it is now guiding us toward the compliant choice. The AI isn't just blindly following rules. It understood the intent of our policy and it is proactively helping us stay compliant. This is the difference between AI that knows your policies and AI that doesn't. Okay, now let's move forward again. I will configure some basic settings and move through the rest of the workflow quickly. The system continues gathering configuration details. I will ask it to generate a simple schema, for example. Now let's skip the remaining advanced settings. There are no additional requirements needed. And the system generated the manifest and it is ready to deploy. Now, notice that the database configuration includes region, East US, thus complying with our policy. Just as before, we could skip this last step and instruct client agent to save the manifest into a file so that we manage it through Argo CD or Flux. As I already mentioned, I was too lazy to set up one of those, so no GitOps today. So, the database deployed successfully with the compliant East US region. But here's where it gets interesting. Let's test what happens when we try to violate our policy. I will ask the AI to modify the manifest and change the region to West US, which, remember, violates our policy that requires Azure databases to be in East US. Now, AI, since now it is not connected to policy, is happily changed the region to West US and it saved the file. It doesn't know this violates our policy because it's just following concrete instructions. So, it's time for the moment of truth. Let's see what happens when we try to apply this non-compliant manifest through cluster. And there it is, the last line of defense. Kyverno blocked the deployment. Even though the AI tried to apply a manifest with West US, because I ordered it to do that, the cluster rejected it because it violates our policy. The error message is crystal clear. Multi-cloud SQL databases must be deployed in approved regions. This is the one for GCP, the one for AWS, and the one for Azure. So, this is the beauty of the dual approach. The AI was guided toward the right choice through semantic search and policy awareness during the creation process. But when someone or some AI tries to bypass that guidance and deploy something non-compliant directly, Kyverno steps in and says, absolutely freaking not. So, without this enforcement, the non-compliant resources would have been created, potentially causing compliance issues, unexpected costs, or performance problems. With it, we have guaranteed that our policies are always respected, no matter how the resources are created. So, let's recap what we've accomplished here. We started with a fundamental problem. Policies exist everywhere and nowhere. They're scattered across documentation, Slack messages, wikis, and most importantly, locked in people's heads. AI agents, like humans, stumble through trial and error because they don't know those policies exist. And the technical implementations, like Kyverno, well, they're bouncers that only tell you no after you already screwed up. So I demonstrated a solution that addresses this problem from two angles. First, we built a guided workflow that extracts policy knowledge from humans through a structured conversation. The system doesn't just collect this information. It generates embeddings and stores them in a vector database, thus making policies searchable through semantic understanding, not just keyword matching. When AI needs to create infrastructure, it can find relevant policies and understand not just the rules, but the intent behind them. Second, we automatically generated Kyverno policies from the same information. Automatically. The system analyzed our cluster CRDs, identified which resources our policy applies to, and created specific validation rules for over 20 different resource types. Hours of manual work condensed into seconds. This gives us enforcement at the Kubernetes level, the last line of defense when someone or something tries to violate our policies. The real magic happened when we saw both aspects working together. When we asked AI to create an Azure database, it proactively recommended the compliant region. The policy wasn't just sitting in documentation somewhere, it actively influenced the AI's behavior through semantic search. The system understood we were creating an Azure database and guided us towards East US, exactly as our policy required. But we also saw what happens when someone tries to bypass that guidance. When we manually changed the region to West US and tried to apply it, Kyverno blocked it immediately. This dual approach ensures policies aren't just suggestions or documentation. They are active participants in your infrastructure management, guiding decisions when possible and enforcing rules when necessary. All in all, this isn't about replacing human judgment or creating rigid systems that can't adapt. It is about capturing tribal knowledge before it walks out the door, making it accessible to both humans and AI, and ensuring that our hard-won lessons and business rules are consistently applied. Whether it is a junior engineer, a senior architect, or an AI agent creating resources, they all operate with the same understanding of what's acceptable and why. The approach itself, the one that I showed, scales beyond just regional compliance for databases. Any policy you can describe can be captured, stored, and enforced this way. Resource limits, naming conventions, security requirements, networking rules, backup policies, anything. If you can explain it, the system can capture it, and both AI and Kubernetes can enforce it. Now, if you're ready to implement this yourself, well, check out the DevOps AI Toolkit project I used in this demo. Try it out, send me your thoughts, open issues if you find bugs or have feature requests. And please, start the repository if you find it useful. Stars help others discover the project and motivate me to keep improving it. This is open source, and your feedback and contributions make it better for everyone. Thank you for watching. See you in the next one. Cheers.